All right, next up on stage is Damien Strazak. Damien Strazak is a researcher and developer with Aleph Zero. Is that correct? With Aleph Zero, he's going to be talking about Ink. Ink, of course, is the smart contract language. Just want to give a special shout out here to Limo. Limo from Nova Wallets is going to be speaking on both stages, I think, over the next 2 days. Good to see you, brother. The Ink language for smart contracts in Substrate. That's what we're going to be hearing from Damien right now. Damien, looking forward to hearing this. Safe, fun, and efficient. Take it away. Give him a round of applause.
Awesome. Thank you for the introduction. And I would like to talk about a very cool smart contract language called Ink, which is developed by Parity. And you're probably guessing that I am a Parity representative. And this guess is obviously wrong. I'm not from Parity. I'm representing Aleph Zero. But we at Aleph Zero love Ink. And that's why we can't help but talking about it everywhere. And that's what I wanted to talk about today. So let's start with this picture, which basically explains us how things work with Ink. So there is this great blockchain library, blockchain SDK called Substrate. And it allows you to essentially build a blockchain out of these very nice pieces called pallets. Okay, so these are some kind of a blockchain modules which are like independent pieces responsible for different parts of the logic. So you have like a pallet balances, pallet staking. There are many different pallets. But for us today, the most interesting one, and I also think it's the coolest pallet ever, is pallet contracts. This is the pallet which you use to have an execution environment for contracts on your Substrate node. Right, so this is Substrate, and using Substrate, there are like a couple of you have like Polkadot, most of all. You have parachains, like Astra, Phala, Pendulum. These are the parachains which employ pallet contracts. And there are standalone chains like us, like Aleph Zero, who also use Substrate and employ the contracts pallet. And then as a developer, you can write contracts in Ink and then deploy to any of these chains. Okay, so this is the pipeline for developers. Okay, and like the main advantage of smart contracts over, let's say, running your own parachain is that it's much simpler. So the pipeline is shorter, you can deliver faster, and this is why we think writing smart contracts in Ink is a really nice way to contribute to an ecosystem. Awesome. So Aleph Zero is a layer 1 chain. We have fast finality, and we have Ink contracts. And our main goal is to bring privacy to blockchain. I will not talk about privacy today. If you want to hear about it, then I encourage you to come to my evening talk at FCC. It is actually after Paris.com finishes today, so I think it's legal to advertise it. So yeah, it will be great to have you there. Awesome. So what's Ink? Ink is a language for writing smart contracts based on Rust. And we all love Rust because Rust is beautiful. Rust is safe. Rust has like really nice features when it comes to security. And yeah, Rust is evolving at a rapid pace. So that's a fact. And like everyone I have ever interacted with who used Rust is never going back, essentially. So whether you are coming from from Golang, whether you are coming from interpreted languages, Python, JavaScript, and if you ever play with Rust and like see all these nice features, see how safe it is, how hard it is to make mistakes in Rust, then yeah, you get sucked into this Rust ecosystem, and it's evolving really nice. So that's why we love Rust, and that's why we love Ink, because it's based on Rust. It compiles down to WASM, which is something much more universal than what the contracts written in Solidity compile into. So this is the comparison. It's taken from the main page of the Ink project, with some small adjustments because it was not really up to date. Anyway, I think one line that I would like to focus on is the bytecode line. So you see that Solidity, which is something which is obviously the most popular language, is compiling to something called EVM bytecode. And yeah, some of you are probably familiar. This is bytecode which was developed specifically for Ethereum, which of course has its advantages, but well, it has also disadvantages, mainly regarding the efficiency. WASM is very universal, it has lots of tooling, and it is actually very fast. So that's something that we like. And what we like even more is that actually Ink is universal. And what I mean by that is that the fact that it compiles down to Rust is only because this parallel contract accepts WASM contracts, right? And there is even ongoing work to make it like to add support for something called RISC-V, which is another bytecode, and there are like lots of hopes as to the efficiency gains that we can get here. So yeah, Ink, really versatile, really nice, and that's what we like about it. Okay, so what's the pipeline here as a developer? So first of all, you need to install a tool called Cargo Contract, and this tool allows you to essentially do everything that you would like to do. It allows you to create a new contract, which essentially generates this some kind of template. Then it allows you to compile the contracts. It will generate these two artifacts. It will generate the WASM file, and it will also generate this metadata file in JSON format. And well, that's it. I will then show you how to deploy such a contract. But now let us just try to go over a very simple contract that we built together. So I must admit that this here on the picture is Pete, and he is normally giving this kind of a presentation as a workshop. So this is a very short version of it. So yeah, I hope to replace him well. I'm sure I will not be so funny as Pete normally is, but yeah, I will try my best. Awesome. So what we are going to do is create a token contract. So this is just some kind of a hello world, pretty much, in the world of contracts. And yeah, I will not go over all this. This is something called ERC20 standard, which essentially gives you a list of methods that such a contract should implement. And there is an analog of ERC20 in the Ink space, which is called PSP22, which is pretty much the same thing, but just specialized to Ink. Okay, great. So here's the first code snippet that you will see today. This is essentially defining the contract. So you see this in contract macro, you see mod Bitcoin, which is defining a module called Bitcoin. And yeah, we'll go further in a second. So yeah, if you are scared by this, yeah, this is how Rust looks like. These lines starting with a hash, these are macros. You don't need to pay too much attention to them, but the rest should be kind of familiar from other languages. Right, so now storage. So what's a contract really? A contract is just a box with some kind of data, right? And this box has some logic attached to it, and this logic essentially says how this data changes inside of the contract based on some outside input transactions. Awesome. So what's the storage here? The storage consists of two fields. It's the total supply, which is just a number, and there is a map with balances, which is essentially, yeah, as you are familiar with hash maps, it's basically saying who has how much money on its account. Okay, so that's the storage. Then we have constructors, which is essentially saying how do we create a contract, how do we initialize it. I will not go over it for the sake of time. And then we have other functions which can either change or allow you to like look at the state of the contract. So in this case, these are like some getters. They are allowing us to look at the total supply and the balance of some account. Again, I will not look into the details here. And then there is this transfer method, which essentially allows you to send some tokens to someone else, assuming you are the owner. So this one is a mutable method, which you can see by looking at the self parameter. So there is a reference to mut self instead of just mut self. Instead of just a reference to self. So this is how the Rust syntax looks like. You have a really nice testing framework in Ink. So you can write either unit tests, you can write E2E tests, which you can test. You can use to like test interactions. So it's a really cool and kind of complete framework for writing and testing contracts. Now I'll just browse through like a couple of screenshots on how do you deploy, and you can deploy using the Cargo contract tool, which is one possibility, and it's good enough, of course. But there is also a second tool called Contracts UI, which is really nice, and I highly encourage you to use it. It's a UI, essentially a web UI for deploying and interacting with contracts. So this is how it looks like. You just upload your contract package, the WASM file, the metadata, and you then specify the arguments for the constructor, and essentially that's it. You can deploy the contract, then you can interact with the contract using any of the messages of the method for the contract you have defined. Then yeah, you can just call these methods. You will be able to see the events, which we didn't talk about, but obviously similarly as for EVM, you have events here. And yeah, it's just a great tool that you can use to test and deploy your contracts. If you want to deploy a full dApp, I mean a contract together with front end, then I encourage you to take a look at Inkaton, which is a very nice tool that simplifies the process. It is written by Denis Zoma from A0ID team, and yeah, it's great, and it allows you to really create a front end with a few clicks and then just customize to it to your needs. So it's a really, really great tool. Something that I also wanted to show you is Drink. It's a project from our team. This is essentially a headless execution environment for contracts. So normally, if you want to run in contracts, you need a node. You need either to connect to a testnet or connect to your local node, or you need some kind of a blockchain node that you can talk to. Yeah, you can actually get rid of it and kind of emulate the node. It is technically not so simple. That's why it took so much time to actually do it. But yeah, this is done in Drink. You can take a look at our repository, and it just simplifies the process of running contracts. You don't need a node. So to conclude, if you are interested in Ink, reach out to us. If you have some cool project to build, we have an open ecosystem funding program. So feel free to apply, and yeah, we'll be happy to have you. Thank you.
Awesome. Thank you so much, Damien. Appreciate that, Damien. I really appreciated that line as well that you said about the Rust language. Once you go Rust, you can never go back. I don't know if anyone can relate to that, but that's quite a powerful line. And I'm certainly going to be tweeting it out. So if you have any powerful little lines that that hit home for you, hit them out on Twitter and get the word of Polkadot and Substrate out as much as you can. Thank you, Damien of Aleph 0, researcher and developer there. Appreciated that talk. Thanks so much, brother.